Happy Tuesday. This is the video for the second half of lesson 1-6, converting with scientific notation. Yesterday we took regular numbers and put them in scientific notation. Today we're going to take numbers that are in scientific notation and make them back into regular numbers, or standard form is the right vocabulary for it. Alright, this is pretty easy. Starting at the decimal point, you're going to move the decimal the same number of places as the exponent. So if the exponent is positive, that means you're making big numbers. You're making numbers in the thousands, millions, billions, trillions, and beyond. So that means you're moving the decimal to the right. Now, on your assignment, I'm going to ask you to do this, to write down like a rough draft of your answer first, and then we'll do a final draft of the answer on the line, okay? So we're going to write down 5.1 underneath. Just copy down this part right here, okay? Now the exponent is 3, so I'm going to take this decimal and I'm going to move it once, twice, 3 times. So now the decimal is here at the end, and I have 2 placeholding zeros that I need to put in, okay? So the first decimal move was around the 1. And then I do 2 more, so that I have a total of 3 decimal moves, and I just fill in with zeros. Now, this answer right here, this looks messy. Okay, when we see numbers, we don't see 2 decimals, an old one and a new one. We don't see these little loopies underneath. Okay, so our final answer is a clean copy of this with just the numbers. Okay, you can put the decimal at the end. If you do commas, remember you start at the end and count in every 3 numbers. If you don't know how to do commas, don't do them at all. I'd rather have you not do the commas at all than do them wrong. The commas do serve a good purpose. They do help people read numbers more quickly. Okay, so let's do that again. Okay, 7.432. And this says times 10 to the 5th power. So we're going to move that exponent 5 times. Well, out of those 5 decimal moves, the first 3 are around numbers. 4, 5. So here's my new decimal. Okay? So I end up only having to add 2 zeros to finish out the number. What a lot of students do is they remember this in elementary school, and somebody in elementary school taught them, oh, just add the number of zeros as the exponent. Well, it doesn't work if you have a decimal, if you have numbers after the decimal here. That does not work. So you have to move the decimal point in order to get the correct answer. And you do not just add 5 zeros. You ended up adding 2 this time. Okay? Okay, so that's positive exponents. If the exponent is negative, that means you're making a very small number. You're making a decimal with lots of zeros out in front. And if you're going to do that, you need to move the decimal to the left. So that's going to be our bottom 2 problems on here. Okay? Here again, I want you to write, oh, you know what though? This is my strategy. If I know that I'm going to be moving the decimal to the left, I give myself some room. So I might start my 8.56 over here to give myself room to move that decimal this way. Okay? So I'm going to take this decimal. The exponent is 4. The negative part just tells me I'm moving it this way, following the arrow. Okay? So here's my decimal. 1, 2, 3, 4. New decimal. Okay? New decimal out in front. 0, 0, 0, 8, 5, 6. Okay, and our last problem. Okay, negative exponent, that means I'm moving my decimal this way to the left. So I'm going to give myself some room to move it. Alright, so here's my decimal. I'm going to move it 2 times. Here's my new decimal. I need one place holding 0, 0.072. Now, you can, if you want, put a leading 0 in front of those decimals. You can do that if you want. It's technically more proper, but you don't have to. Okay? It is perfectly acceptable to leave your answers just like that. Okay? On your homework, let me get that opened up. Down at the bottom, okay, we've got briefly explain why each number is not correct scientific notation. Okay? So, just a reminder of what correct scientific notation looks like. Whoops, I didn't mean to open that. Okay, at the bottom, you're asked to explain what's wrong with a scientific notation. So try to remember what real scientific notation looks like in order to be correct. First, you have a single digit number and then a decimal. It can't be 2 digits, it can't be 5 digits, it can't be no digits. It has to be a single digit number from 1 to 9. Okay, then you're going to have a decimal and some other numbers after it. Okay, it could be 1 number, could be 3 numbers. It just depends on how many numbers were in the original problem. Then you should have, and I'm going to have to squish this in a little bit, a times 10. It's never any other number. It's always times 10, and it's always multiply. Not add, not subtract, not divide. Scientific notation is always a multiply sign. It's actually one of the few things this year where it's okay to write the x for times. Okay? And then you should have an exponent here. Okay? So that's what real scientific notation should look like. So if I were doing number 29, what I'm noticing is that this is the part that's wrong. You can't have a double digit number in front of the decimal. So it says explain why each number is not written correctly in scientific notation. So you would just write a sentence like the number in front of the decimal is not single digit. Something like that. Okay, so pick out what's wrong with each one and just write a quick sentence about it. Thank you very much. This homework assignment is due tomorrow. Have a great day.